grade sixes, and welcome to your daily mathematics lesson brought to you by WorksheetCloud.com. Hope you guys are enjoying the new format with a lesson every second day, and I hope that you've been able to consolidate the work from each day now that we've given you a little bit more time. Just remember about the online activities and memos that you have available to you. There's quite a lot there for you to do. You don't need to do all of it, just as much as you can until you completely understand the concept that's been taught to you. And then just a reminder about the email address on your screen. Please use it. Send me any questions or queries about any mathematical content that you would like me to cover or like me to clarify. Okay, so today's theme is measurement. And then on either side of that, we have our warm-ups and challenges and finishes, which I hope you guys are still enjoying. And let's get into the first one. So you should know by now that you are required to tell me the value of each symbol. And today we have a bacteria, a DNA molecule and a molecule. Sorry, DNA helix and a molecule. And then don't forget the question mark at the end. Those brains are working this morning. If you're thrown in a few numbers there and got it wrong and then tried again, then well done. But you should have had 9 plus 11 plus 9. Okay, that gives you 29. So I know my bacteria is 9. The molecule works out to 15. And we know that order of operations, 15 multiplied by 9 comes first. Okay, 15 multiplied by 9 is 135. Then add the 9 to 144. Then 15, add 11, add 15. You put those three together and you're going to get 41. And then I'm just left with 11. Double molecule will be 30. Double bacteria, sorry, that should be multiplied. Double bacteria should be 18. Okay, and now you need to do 30 multiplied by 18 first because order of operations, multiply comes before addition. So here you can do a multiple number of ways. I can say 3 multiplied by 18 is 54. And then add the 0 to 540 and add the 11 to 551, 551. Or I could maybe do doubling and halving. So perhaps I could double the 30 to 60 and halve the 18 to 9. Now I've got 60 multiplied by 9, 6 times 9, 54. Put the 0 there, 540. And again, you can see how those mental strategies we've been talking about over the last few weeks can become really, really handy. Okay, so either way, your final answer is 551. Okay, right, well done if you worked through that. There are your mental mathematics questions for today. Read through them very carefully. I'm not going to read them for you today. You guys need to get used to reading them and figuring out what you need to do by yourselves. But you read carefully, make sure you understand whether I'm looking for one thing or two different things. Please check your work as we've discussed over the last few weeks, and let's see how you guys remember the past principles. Question number 1, Sean's salary is 795 Rand and 63 cents a month. Round off his amount to the nearest 10 Rand and then find his approximate annual salary. So we're looking to do two things. The first thing, we need to round off this number to the nearest 10 Rand. And we can see that the unit is 5. So we know that if it's 5 or more, then it goes up to the next 10 Rand, okay, which will be 800 Rand. And then his annual salary, annual is yearly. So there are 12 months in a year. So I need to go 12 multiplied by 800. And there we can go 12 multiplied by 8 is 96. And then we need to add those other, or the zeros from the 100. Alternatively, you could double and halve and say double 800 to 1,600. Half 12 to 6. Let's actually write that down so we can see what it looks like. so 6 multiplied by 1,600. Then again, 3 multiplied by 3,200. And 3,200 multiplied by 3 will give you the 9,600 as well. Okay, so there again, choose the method you prefer and the one that makes the most sense to you. But yeah, again, I'm just highlighting that you don't need to do a long column method strategy. So yeah, practice those other ones. 0,09 multiplied by 12, and again here you've got options. You can either turn it into fractions, so that's 9 over 100 times 12 over 1. I could say 9 multiplied by 12 is 108 over 100, and that gives me 1,08. Okay, so that's your answer. Alternatively, I could have simplified diagonally, okay, and we know that 4 goes into 12 3 times, and 4 goes into 125 times. Okay, and then we could have done 9 times 3 is 27 over 25. Okay, that would have been a bit tricky to work out the decimal from there. But if you wanted to, you could divide 27 by 25, and you'd get 1,08. You could also, as we spoke about when we dealt with decimals, I could take the decimal out of the question, so multiply that by 100, and I get 9 multiplied by 12, which gives me 108. Okay, and then because I multiplied by 100 in the beginning, I need to divide by 100. And 108 divided by 100 gives me 1,08. So I think either converting it to a fraction or getting rid of the decimal by multiplying by 100 and then putting it back by dividing by 100 at the end will probably be your two most straightforward methods. As I showed you, if you had simplified diagonally, it would have given you quite a tricky sum at the end. Okay, just going back to, let's just have a look at how, if you had done this, if you had ended up with 27 over 25, how would you have turned that into a decimal answer? Well, that we know is 1 and 2 over 25, okay, which is the same as 1 and 8 over 100. Okay, so I've got to multiply the denominator 25 by 4 and then multiply the numerator 2 by 4, and then we know that that's 1,08. Okay, so there are your three options. Choose which one you prefer and give it a shot. I would encourage you to try all the different methods that we are talking about, because you never know, one might just all of a sudden make a lot more sense to you. Question 3. This chart shows the distances traveled by a motorist in 3 hours. Find his average speed in kilometers per hour. So if we add up the distances, he's got 85, 110, and 75. Okay, we add those up, that gives me 270 kilometers in 3 hours. Okay, so if I want to get it to 1 hour, I divide 3 by 3 to get 1 hour. So I must therefore divide 270 by 3, and that's going to give me 90 kilometers per hour. Okay. And then question 4 is an angle question, and they want to know the sum of the angles in a triangle. So the first thing you should be saying to yourself is, yes, I remember we spoke about that. Sum of the angles in a triangle add up to 180. Okay, so for a triangle W, I've got 78 and 51, and that adds up to 129. Okay, so what do I need to add to 129 to get to 180? And yes, that's 51 degrees. Okay, so that's for triangle W. For triangle X, we've already got 60 and 71, and that is equal to 131. Okay, so I need another 49 degrees for triangle X. Okay, and that will give me my 180. And triangle Y, if you add the angles that are given to you already, it's 130. And we know that we need 50 more degrees to make up 180, which all the angles of the triangle add up to. Okay? Great. And then question number 5. Let's clean some space. Find the product of 1 2/3 and 30. Okay, so remember, product is the name given to a multiplication, given to the name of the answer of a multiplication question. So the first thing I'm going to do is convert that to improper, and I'm going to convert 30 to a fraction, so I'm dealing with 2 fractions, so it just makes a little bit more sense. Now you can either say 5 times 30 is 150, and then 3 times 1 is 3, so you've got 150 over 3, which is 50. Okay, alternatively, you can cancel out diagonally. 3 goes into 3 once, and into 30 10 times, and then 5 times 10 is also going to give you your answer of 50. Okay, I'm hoping that you guys are remembering these past principles that we've been going through over the past few weeks. Please feel free to go back and have a look at the lessons if you don't understand rounding off of decimals, or multiplication of decimals, or multiplication of fractions, or angles in a triangle. Go have a look at the videos. They're there for you. Go have a look at the online activities and memos to try and consolidate that information. But yeah, I really encourage you to make the most of the opportunities that we're providing for you. Okay, so today we're going to have a look at measurements. Okay, and the first thing we're going to talk about is the metric system. So the metric system of measurement is based on powers of 10 and uses the following prefixes. So just quickly on the based on powers of 10 is we either multiply by 10, 100, or 1,000, or we divide by 10, 100, or 1,000 to convert between measurements of units. Okay, and 10, 100, and 1,000 are all multiples of 10. So 10 is 10 to the power of 1, 100 is 10 to the power of 2, 1,000 10 to the power of 3. So that's what they mean when they talk about a base 10 system. Okay, so kilo means 1,000. It's either Greek or Latin. So yeah, kilometer, 1,000 meters. Kilogram, 1,000 grams. Kiloliter, 1,000 liters. Okay, so kilo means 1,000. Okay, then we have centi, and centi means 100th. Okay, so centimeter, centiliter. Okay, so we know that 100th. Then we have milli, and milli means thousandth. Okay, so millimeter, thousandth of a meter. So a milliliter is 1,000th of a liter. Okay, so there are 1,000 milliliters in a liter. Okay, and then micro, which we don't often see a lot of in grade 6 and 7, means a millionth. Okay, so that's just something for you to keep in the back of your mind for when you do eventually see micrometer, micromillimeter, or something along those lines. It means 1 millionth. Okay, so as we've spoken about, the prefixes are then followed by base 10 units. So that would be meter. Okay, so you would know that you have gram for mass, meter for length, and for capacity would be liter. So guys, I thought it would be a good idea just to go through multiplying and dividing by 10, 100, and 1,000 again, as this is really the backbone of how we convert between units of measurement. So on the screen, you've got different units of measurement that I'm sure you're all aware of. And each unit of measurement works a little bit differently. So we know that distance is millimeter, centimeter, meter, kilometer, weight grams and kilograms, and capacity milliliter and liter. And as we've already said, you need to be able to multiply and divide by 10, 100, or 1,000 to change from one unit of measurement to another. So let's have a look at what we would do with centimeters and meters. So we know that there are 100 centimeters in 1 meter. So to get from centimeters to meters, we divide by 100. Okay? Now, when we divide by 100, as you can see on the screen, we're looking at 427 centimeters. How many meters is that? So I've got my numbers in my place value columns. So 400 in the hundreds, 2, which is 20 in the tens, and 7 units in the units column. Obviously nothing in the tens, hundredths, or thousandths column after the decimal. So when I'm going to divide by 100, my numbers get 2 places smaller. Okay, so there it's 1 place smaller, 2nd place smaller, and now the 4 and the 2 need to shift up 2 places, and there we're left with 4,27 meters. Okay, so therefore 427 centimeters equals 4,27 meters. So there are 3 for you to do. I'll give you a couple seconds to work through those, and let's see if you guys can get the correct answer. 326 centimeters, I need to divide that by 100, and you would have been quite correct if you had said 3,26. So there you can see the 6 moves 2 places from the units to the hundredths, the 2 moves 2 places from the tens to the tenths, and the 3 moves 3 places from the hundreds to the units. 47,6 centimeters, you would have been correct in saying 0,476 meters, and again we're dividing by 100. There are 2 zeros in the number 100, so that tells us how many places the numbers must move. Notice the decimal always stays in the same place, so the 6 goes from tenths to thousandths, the 7 goes from units to hundredths, and the 4 goes from tens, because it's 40, so 4 tens, and it ends up in the tenths column. 465.3, you would have been correct in saying that that's 1,653 meters, and you can see how the numbers move 2 places to the right. Okay, so there's some more practice for you. I'll give you guys some time to work through it. Press pause. When you've worked through those 7 examples, press play and see if you guys have mastered that skill. So there's 354 centimeters in meters. In the next one, 15,4 centimeters, 0,154 meters. And I'll just put these on the screen. I don't think I need to read them to you. I'm sure you guys can read off the screen comfortably. And just make sure that you recognize that each number from centimeters is getting 2 places smaller because we're dividing by 100. Okay, so now we want to go the other way. Now we want to go from meters to centimeters, and here we just do the opposite. So we multiply by 100. So there you can see it says, remember, when we multiply by 100, we move each digit 2 places to the left because now they are getting bigger. Okay, so there you can see the 3 will move 2 places from the unit to the 100, the 5 will move 2 places from the tenth to the 10, and the 1 will move from the hundredth to the unit, and 3.51 meters is 351 centimeters. So there are a couple for you to practice. Press pause and let's see how you get on. Answers and put them up on the screen for you to read off. And again, just notice that each number gets 2 places bigger. And yeah, I encourage you guys to make sure you fully understand these concepts. Okay, so I think I've mentioned this quite a few times, so I'm just putting this up on the screen so you have a point of reference, so that if you ever need to go back and have a look at conversions for length, then you can just go back to this video and have a look at how many meters in a kilometer, centimeters in a meter, etc. Just be aware that you may not be asked straightforward conversions. 1 kilometer, how many meters? I mean, that's pretty straightforward. You might be now getting to an age where you might be asked how many millimeters are in a meter. Okay, so up to now you might have been asked how many millimeters in a centimeter, it's only one conversion, or how many meters in a kilometer, again you only have to convert once. But if you asked how many millimeters are in a meter, you'd first need to go to centimeters and then to millimeters, and I would encourage you to do that conversion twice just to make sure, until you're fully comfortable to do meters directly into millimeters. So a little tip there is to go meter, centimeter, millimeter, or kilometer, meter, then centimeter, then millimeter, and not directly from kilometer to millimeter if asked. That's just to avoid any careless errors. Okay, so here's a question or an example of a measurement question. A racetrack measures 400 meters. An athlete runs 2.6 kilometers around the track. How many laps is this? So there's something that you need to do first before you can work it out, and let's see if you can go and figure that out. This is 0.4 kilometers, and I'll talk you through two different ways of doing this. So the reason why we've converted the meters into kilometers is because in the question there's 400 meters and then there's 2.6 kilometers. Now it's very important that you have the same units of measurement throughout your calculation. Okay, so that's why we've converted 400 meters to 0.4 kilometers. So we need to now divide 2.6 by 0.4 to see how many laps this athlete has run. And you should know 2.6 divided by 0.4, 6.5 laps. You can go work that out. I would have also said, you know, you can convert the 2.6 kilometers to 2,600 meters, and then you could have done the same calculation and you would have got 6.5 laps. Okay. Then the second part of the question, the following day the athlete completes 8 laps. How many kilometers is this? So 8 laps, you know that it's 400 meters per lap, so 8 times 0.4, and that's going to give you 3.2 kilometers. And if we go onto the Jamboard and we just go have a look at how we could have done this using a different method. So we know we had 2.6 kilometers and it was a 400 meter track. Okay, and so in that example I worked through, they used kilometers. So if I use meters, and now I need to know how many times does 400 go into 2,600. Okay, that's exactly the same as doing this. Okay, you can write it as a fraction. You can see straight away that both numbers can be divided by 100. So that will leave you with 26 over 4. Okay, both of those numbers can be halved again. Right, and how many times does 2 go into 13? Yes, 6. And it leaves me with the half. And that's the same as the 6.5 that they worked through earlier. And then the second part of the question was if he had run 8 laps, okay, how far would that have been? And again, if you had just used meters, you could have said 8 times 400. Okay, we know 8 times 4 is 32, and we need to include the zeros from the 400, and there you've got your 3,200 meters. Okay, and yeah, we know 3,200 meters is 3.2 kilometers, because 3,200 divided by 3,200 meters divided by 1,000 gives me 3.2 kilometers. Okay. Right, sorry, we've already been through this one. Okay, so now we move on to metric units of mass. Okay, so those are tons, kilograms, grams, and milligrams. And it's important for us to know how many milligrams are in a gram, or how many grams are in a kilograms, or kilograms in tons. So just for your reference again, 1,000 kilograms in a ton. 1,000 grams in a kilogram. Remember, kilo means 1,000, so it's saying 1,000 grams already, and 1 gram is 1,000 milligrams. And again, the same with the length. Know how to get from kilograms to milligrams. Okay, and again, I would encourage you just to go from kilograms to grams and then to milligrams. So here's a question for you. 60 tea bags weigh 150 grams. How much would 2,000 tea bags weigh in kilograms? Okay, and what we've done here, they talk about a unitary method. So if 60 tea bags weigh 150, then we need to work out what 1 tea bag weighs. And these are similar to the questions we've done in your mental maths, where I've asked you to work out kilometers per hour when I've given you so many kilometers in like 3 hours. So it's a similar concept. 1 tea bag weighs 2.5 grams. Therefore, 2,000 tea bags is 2.5 times 2,000, and that gives us 5,000 grams. And we know that 1,000 gram is a kilogram, so 5,000 grams is 5 kilograms. Okay. This takes us on to capacity. So capacity is how much liquid a 3D object can hold. So for example, they've given you a glass, but like a 2-liter bottle or 1.5-liter bottle. What is the capacity of that? Okay, and that is measured in liters, centiliters, and milliliters. And we predominantly use liters and milliliters, but it's a good thing for you to know centiliters as well. So there are 100 centiliters in a liter. There are also 1,000 milliliters in a liter, and 1 centiliter equals 10 milliliters. Okay, so again, I would encourage you, if you ever had to convert from liters to milliliters, you know it's 1,000. From liters to centiliters is 100, and yeah, use this screenshot or come back to this video so that you have that information at hand. So a question for you, a bottle contains 750 milliliters of orange squash. The label says dilute 1 part squash with 4 parts water. How many liters of drink can be made with 1 bottle? Okay. And there, if the whole bottle was made up, we would have 750 milliliters of squash, and that would be our 1 part squash. And then we'd have to have 4 parts water, so we'd have to have 4 times 750 milliliters of water. Okay, and that's how we would mix it into the correct ratio. So for that, we know that's 4 times 750 is 3,000. We need to add them together, and that's how many milliliters of drink we have. And we know to get from milliliters to liters, we divide by 1,000. And when we divide by 1,000, our number gets 3 places smaller. And you can see that 3,750, 3 places smaller is 3,75. Remember, I don't need to have 3,750. I can leave that 0 off, and it's exactly the same as 3,75. Okay, so let's just have a look at the following. You guys need to fill in the missing word. Okay, so to convert from a larger metric unit to a smaller one, we need to give you a couple seconds. We need to multiply by 10, 100, or 1,000. So an example there is 1 kilometer. How many meters? I must multiply the 1 by 1,000 to get to 1,000 meters. Okay. If I asked you to complete the following, so how many millimeters in 34 centimeters? That's correct. I would multiply by 10, and that would give me 340 millimeters. How many milliliters in 0.4 liters? 400 milliliters. And remember, to get from liters to milliliters, I multiply by 1,000. So 0.4 multiplied by 1,000 is 400. To get from kilograms to grams, I multiply by 1,000, and yes, you would get 7,300. to get from centiliters to milliliters, what would you multiply by? You would multiply by 10. Okay, and there you can see that 54,8 gets one place bigger to 548. Okay, this one might be a little bit more tricky because there are more places involved. But to get from kilometers to meters, you should straight away be saying, okay, I'll multiply by 1,000. So 0,471 to get 3 places bigger will be 47,1. And feel free to write the number down and actually draw in, okay, 1 place, 2 places, 3 places. That's obviously, fine to do. And quite often when you actually make it visual for you, it's easier to understand. To get from meters to millimeters, okay, so here's one of the examples where I said, normally we'd go from meters to centimeters and then to millimeters. So if you went from meters to centimeters, you would multiply by 100, so 34,28. And then to get from centimeters to millimeters, I multiply by 10. So ultimately here I'm multiplying by 1,000, and you should get 342,8. But I just find it a lot easier to understand if I first go from meters to centimeters, okay, and then from centimeters to millimeters. And then again, from grams to milligrams, you're going to have 23,51 multiplied by 1,000, and that's going to give you 23,510. Your last one on the page, again from meters to millimeters, and either multiply by 100 and then by 10 to go to centimeters and then millimeters. Alternatively, you can just multiply by 1,000 straight away if you're at that level where you can recognize that conversion immediately. Okay, and then to convert from a smaller metric unit to a larger one, so to go from like a milliliters to a liters or millimeters to meters, quite right, the missing word is divide. And here's some examples for you to work through, and I'll give you a few seconds for each. So 920 millimeters, you should be saying divide by 10 to give me 92 centimeters. 530 grams, okay, how many kilograms? Divide by 1,000, 0,53. Milliliters to liters, divide by 1,000. Centimeters to meters, divide by 100. Meters to kilometers, divide by 1,000. Milligrams to grams, okay, you divide by 1,000 again. From centiliters to liters, you would divide by 10. And from kilograms to tons, you would divide by 1,000, and that would give you 0,087. Okay, so I hope that conversion lesson helped you understand what you need to do and how those units of measurement work. Please feel free to go back and have a look at this video. Have a look at the online activities I've left for you guys today. I've left you loads of practice and loads of examples to work through. You don't have to work through all of them, but just make sure that you practice and consolidate the information as much as possible so that when you do encounter these kind of problems moving forward at school, then you don't have any problems or don't make any careless errors when working through them. Here's your brain bender for today. As you can see, the magic numbers are mentioned in the first and the third one. Okay, so you just need to figure out how to work out 38 to make rows, columns, and diagonals. The second one, you need to actually work out the magic number yourself. And the third one, they've given you the magic number. So you need to work out how the rows, columns, and diagonals work there. So go back to this, press pause, draw them out, challenge someone at home, have a bit of fun with it, and yeah, see who comes out on top. And there's your 24 challenge for today. You guys are very close, I think 1 or 2 away from moving up onto the blue level. And yeah, I encourage you to find as many different ways to get the answer of 24 using all 4 numbers on each card and a combination of operational signs, or perhaps just one sign. And yeah, let's see how you guys get on at home. Grade 6s, thanks very much for tuning in today. Quite a lot of information to get through, and as I've already mentioned, your online activities and memos are there for you to help consolidate. And remember, you can always go back to those online activities in a day or two and just keep refreshing these principles in your mind. A reminder of the email address, grade6@worksheetcloud.com. Please feel free to use it at any time. Guys, keep safe. Enjoy the company of those around you, and I'll see you guys soon.